Welcome to my YouTube channel Statistics for Beginners. Today we will be discussing about the topic correlation, which is a statistical tool to observe the relationship between two variables or more than two variables. So we are moving forward. The definition of correlation is given as it is defined as a statistical tool to measure the relationship between two or more variables in terms of magnitude and direction. The variables are said to be correlated if the change in one variable affects a change in other variable. If it is calculated for more than two variables, it is known as multiple correlation. Now, some of the agriculture example has been given here about the simple correlation between two variables. One variable could be incidence of pest and weather factors, where we have observed that some of the pests could multiply themselves in certain kind of cold weather or warm weather. The second example could be crop yield and pest incidence. The third example, size of farm and income, etc. And there are numerous other examples also that we can observe the correlation between them. There are basically three types of correlation. One could be positive correlation, one could be negative correlation, and one could be no correlation. Okay, so here we are discussing about positive correlation. If the two variables move in the same direction, that is, if the increase or decrease in one results in a corresponding increase or decrease in the other, correlation is said to be positive or direct correlation. The examples are given as income and expenditure. If a person's income increases, his expenditure will also increase. And there is some kind of correlation, positive correlation between height and weight of a person. Okay. Then there are some other positive correlations are also there. And the second type is negative correlation. If a decrease in one variable causes an increase in the other variable or vice versa, the variables are said to be negatively correlated. These variables will constantly move in the opposite direction. It is also known as inverse correlation. Now, one of the common example of negative correlation is price and demand. When a particular commodity price increases, demand in the market decreases, whereas if its demand increases, the price of the commodity decreases, like this one. And even the pest incidence and crop yield, the yield of the crop will increase if the pest incidence will be low, and if the pest incidence of a certain crop is high, then its crop yield will be low. If the variables are independent to each other, they will not have any correlation. The correlation is not merely a mutual association between two variables, it implies a cause and effect relationship between the variables. So related to correlation, there is also one of the statistical tool known as regression, which shows a linear relationship between the dependent and independent variables. So before doing regression, we have to observe the correlation between them also. So we cannot just simply take two variables and observe their correlation. Just like we cannot compare mango with banana, or similarly it is a metaphor, like we cannot compare two variables which are not related to each other. Okay, there should be some kind of cause and effect relationship between them, then only we can observe the correlation. Now, one of the graphical representation to observe the correlation is a scatter diagram. It is the simplest way of diagrammatic representation relationship between two variables. If we consider two variables, here we have considered, say, x is one of the variable and y is one of the variables. So these are the coordinates of x and y. That is x1 and y1, x2, y2, like this way, x and yn. Be n pair of observation. If the values of the variables x and y are plotted along the x-axis and y-axis respectively, the resultant diagram is known as scatter diagram. So this is one of the example that has been considered to observe the scatter diagram of the two variable of the to observe the scatter diagram of these two variables. One variable is considered in the example as selection test, and the other is considered as proficiency test. These are the marks that has been given, and here 10 observations are there. Sorry, not 10. Yes, 10 observations are there. This is the scatter plot that has been plotted against x and y values of the marks that has been given in the data. Now from the scatter diagram we can form a fairly good though vague idea whether the variables are correlated or not. If the points are very dense, that is very close to each other, we should expect a fairly good amount of correlation between the variables. If the points are widely scattered, a poor correlation is expected. So this diagram, this scatter diagram is not very much, we cannot give a conclusion regarding this correlation between proficiency test marks and selection test mark. It is just a example that is being considered here, but we require more points to observe the clusteredness of the points or scatteredness of the points. Okay, then only we can give a conclusion with respect to the scatter diagram, that either they have a fairly good amount of correlation or they have not any kind of correlation. This is some of the with the help of scatter diagram we have observed the graphical representation of correlation. Here we will be getting one quantitative figure with the help of this formula that has been developed by Carl Pearson. He has contributed other important aspects in statistics. So coefficient of correlation for two variable we can calculate with the help of this formula. That is denoted by small r equals to covariance between x and y divided by standard deviation of x to standard deviation of y. Okay. So this is one of the simplest version of that particular formula, and this is a unit free measure. Okay, this doesn't consist of any unit. Carl Pearson coefficient of correlation, and it lies between -1 to +1. When the value of small r equals to 0, the variables are said to be uncorrelated. When the value of r equals to 1, the relationship between the variable is perfectly positive. Similarly, for r equals to -1, the relationship between the variable is perfectly negative. Okay, so it is very much difficult, or it might be some kind of coincidence if we get two variables which are perfectly correlated negatively or positively. So we'll be getting mostly the values in between -1 to +1 only, and the correlation, no correlation value, that is r equals to 0, is also very much difficult to get for two variables. Okay, so if we by chance get some kind of values of correlation coefficient for such kind of variables, then they will be perfectly correlated or perfectly negatively correlated or perfectly positively correlated. Now we have considered some of the problems that could be practiced with the help of this correlation coefficient formula. One is here considered as a height of fathers, that is in inches, as well as the height of son has been considered. So two variable has been considered, height of fathers and height of sons, and these are the observations of say 8 fathers and 8 sons. Now we can calculate the correlation coefficient from this particular data, and we can observe either they are positively correlated or negatively correlated. Okay. Now this is one of the second example that has been considered here. This is the 10 student marks of mathematics and statistics. Okay, so mathematics marks has been given of 10 student, as well as statistics marks has been given, subject statistics. So here also we can observe the correlation coefficient, the relationship between the two subjects, mathematics and statistics. And this is also some kind of data of say 7 observations of some kind of variables, say x and y. So these also, from these also we can calculate the coefficient of. So in the books of statistics we have numerous problems related to calculation of coefficient of correlation. Okay. Now till now we have discussed the Carl Pearson coefficient correlation, the variables which are in quantitative values. Okay, the variables like age, weight, marks of students, these are all quantitative variables, values that will give us values in quantitative figures, and we can calculate their correlation. But whenever we came across such kind of variables like qualitative, and for such kind of variables we have to calculate the correlation, then we have to shift towards our second part of this concept of correlation, that is rank correlation. Now let us suppose that a group of small n individual is arranged in order of merit or proficiency in possession of two characteristics, beauty and intelligence. The ranks assigned in these two characteristics will be different. It is not necessary that a beautiful individual is intelligent also. Let small xi, small yi I goes from 1 to n be the ranks of the ith individuals in the Beauty and intelligence. The coefficient of correlation between the ranks is called rank correlation for that group. Now, this rank correlation is valid in case of the variables which are qualitative in nature. Now, beauty and intelligence, these are quality of a certain kind of individuals. Okay, so in this also slide, it has been considered n individuals which have two characteristics. One is beauty and one is intelligence. So we can rank them and we can calculate their rank correlation. Okay, because beauty and intelligence, we cannot get some kind of quantitative figures like our age, weight, height. We have to rank them to observe their correlation also. Now for this rank correlation, Spearman has given this particular formula, rho. It is denoted by rho equals to 1 minus in the numerator per 6 summation d square divided by small n square. So these are two of the formulas that has been discussed in this video regarding correlation. One is for quantitative values like variables like age, weight, height, or some kind of other variables where we can get quantitative values, we can observe their correlation. And one is about the qualitative characteristics of certain kind of variables where we have to rank them first, then only we can observe their correlation. So in the coming lectures we'll be discussing about regression. So I hope all you have understood this small and important topic regarding statistics. These are some of the data that could be used to calculate the rank correlation coefficient.